All right, here we go. So our very first lesson, this is on the unit circle, degrees, and radians. If you were in Algebra 2 Pre-AP last year, you would have already had some experience with this, so this should be a review lesson. If you weren't in Pre-AP, maybe a little catch-up for you, but this is unit circle. Why is it called a unit circle? Unit means the unit of 1 and has a radius of 1. That's why it's called a unit circle. So we have a circle with radius 1. We have a couple of different special values on our unit circle. Some of the values are created by a 30, 60, 90 right triangle. Yes, you can calculate these values by doing a 30, 60, 90 right triangle, but you're really going to need to commit them to memory. You won't have time to do triangles every time you're asked a unit circle value. Unit circles, huge. I mean, we use it in calculus. It's something that really needs to be embedded in your memory. So if you have a 30, 60, 90, we have root 3 over 2, 1/2 are the coordinates at 30 degrees, or pi over 6, whether you're doing radians or degrees. Then a 45, 45, 90 is root 2 over 2 over root 2 over 2. So just kind of a reminder. On the second slide, you'll see the unit circle, and we'll talk about it a little bit more. I will have 2 slides per lesson. That's it. Okay, 2 slides per lesson. So here's our first slide. We're talking about in general about unit circle. So we have, if you recall, these definitions are pretty important to us. You know, the SOHCAHTOA thing, right? Sine is opposite over hypotenuse. Maybe, hopefully you remember that from geometry or reviewed it. So let's look at, you know, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and so forth. So that, just reminders. The other thing that we're going to be doing today is we're going to convert from degrees to radians and radians to degrees. These are our conversion factors, either 180 over pi or pi over 180. If you think about it like you would dimensional analysis. Now, radians typically have pi in them. They don't have to, but many times they do. So if you have a radian and you want a degree, then you would want the pi on the bottom, right? You'd want it on the bottom so that you could cancel out the radians. That kind of hopefully will help you remember which way to put the fraction. If you have a degree and you want to go to radians, then you multiply by pi over 180. So it's either going to be 180 over pi or pi over 180, depending on which direction you're going. Okay, hopefully that is a review. We okay so far? Okay. See if there's anything else we need to talk about. No, let's go to the second page. Here's where we'll do some practice. All right. Get this out of the way. So the first thing we're going to do is we're going to convert. We're going to convert from degrees to radians or radians to degrees, depending on just which way we're going. Really important is this little degree symbol, the little degree symbol. If you don't put it there, then you're giving me an answer in radians. Okay? So critical that you have the degree symbol there. If you just write 45, then you're telling me you have 45 radians. Okay, without the degree symbol, it's a radian. So this is a degree, and we want to go from degrees to radians. So here's where we want the pi, right? So we're going to multiply by pi over 180. Then we simplify all that, because we always want our answer in simplest form. So that turns out to be pi over 4. Now I'm going to go to number 3 next, because that's really obviously a radian. Number 1 is obviously a degree, and number 3 is obviously a radian. You know, I've got the pi in there, and there's no degree symbol. So if I want to convert from radians to degrees, then I multiply by the other one, which is 180 over pi, right? Because we want to cancel the pi's out. You know, if you think about dimensional analysis, we want to get rid of that. So we do that, and we simplify, and we get negative 120 degrees. Okay, so those are just standard regular ones. Now let's look at number 2. Number 2 is written in degrees and minutes. We will be working with degrees, minutes, and seconds. I think that's important. It's been around for a really, really long time. and I have the little note here, it's actually been around since the Babylonians, really long time ago, where they decided that there should be 360 degrees in a circle, and then they used that to navigate, and then 1 degree is 60 minutes, and 1 minute is 60 seconds. And so that is the degrees, minutes, and seconds still used today in navigation and other ways. So it helps us get very precise. So what we would do here, it will be a calculator problem, but I don't want you to just be hitting DMS in your calculator. I mean, that's boring. I need you to understand how does it work? What are you doing? I'm going to convert this to, it is in degrees. I want to convert it to radians. So this really means 57 plus 18 over 60 is what that means, right? That's the quantity that we're looking at. And I would multiply that, and I'm in degrees, I want radians, I would multiply that by pi over 180. And in doing that, I get 1.0007. Basically, this measurement is almost exactly 1 radian. 1 radian is about, a little bit more than 57 degrees. That's what 1 radian is. Okay? Then this one, 0.62, you're like, oh my gosh, what's that? Well, there's no degree symbol, so we know it has to be a radian. It has to be a radian. So this is a radian, and we are converting to degrees, so we want to do 180 over pi. And since we start with a decimal, we want to end with a decimal. So I would put that in my calculator, and I would get 35.523 degrees. Okay, questions on converting from radians to degrees or back and vice versa? Pretty straightforward, right? Hopefully this is just a review. All right, now we're going to go to find an exact value of the function. This is going to be more typical for us. What is cosine of 4 pi over 3? Well, let's talk about the unit circle a little bit more. Cosine is the x-coordinate of these coordinate points, and sine is the y-coordinate. Okay? So if I asked you what is sine of 60 degrees, you would tell me the y-coordinate. You would tell me it's root 3 over 2. Okay, that's how it works. If I asked you what cosine of 90 degrees or pi over 2 is, you would tell me it's 0. Right? Cosine is associated with the x, and sine is associated with the y. Now, let's talk about these radians. Okay, so I'm just saying, radians are the best. They are the best. I don't want to hurt degrees feelings, but radians are the best. So we need to be sure we understand how to write these radians. Now, I'll tell you what I do. I've done this for a very long time. It helps me with my memory work. I count by sixths if I'm doing a 30, 60, 90. Or I count by fourths. So for example, this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which of course if we were going to if we were going to write that down, the 4 pi over 6, we would reduce it to 2 pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. I just count all the way around in sixths, and it tells me where I am. 7 pi over 6, 8 pi over 6, 9, 10, 11 pi over 6. If you count to round and then just simplify, you get those radians. You don't have to memorize it. Just count to where you need to go. If you do the fourths, you count by fourths. So this would be the first one would be like 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, so forth, all the way around. That will help you with radian measures if that's kind of just like totally foreign and weird to you. If you count in sixths or fourths, you will get to the radian measure that you need. Okay? So, just a little hint. However you want to do it is whatever you want to do. So, that is our unit circle, and here we're asked to find cosine of 4 pi over 3. So what do? We'll have this memorized. We go to 4 pi over 3, which happens to be right down here, 4 pi over 3, and cosine is our x-coordinate, right? Cosine would be the negative 1/2. So we would say cosine of 4 pi over 3 is negative 1/2. Right. tangent. Now tangent's not on here, is it? Tangent is not sine or cosine. It's actually a combination, right? Tangent is sine over cosine. Maybe you remember that, maybe you don't. Tangent is sine over cosine. So what I'm going to be going to 60 degrees, and I'm going to, make myself a fraction. It's going to be sine over cosine. So sine at 60 degrees, is the y coordinate, so root 3 over 2. Cosine, which is the x one, is 1/2. Okay, so then I fix my complex fraction by taking the bottom one and flipping it up, right? And so I get root 3. Basically, on the unit circle, tangent and the 30, 60, 90s is either going to be root 3 or 1 over root 3. And that's what's going to be. I don't like to memorize it. I would rather write it out. You can memorize it if you want to, but I would rather write it out and just work it like that. So there's our root 3. Are we okay so far? All right, this number 7, basically, we're just doing multiple things of what we did in 5 and 6. We're just going to find all those unit circle values, and we're going to do arithmetic, combine like terms and such. So we want sine of 2 pi over 3. So here's 2 pi over 3. Sine is the y coordinate, so that is root 3 over 2. Then we want cosine of 5 pi over 6. So 5 pi over 6 is right here. Cosine is the x coordinate. So that would be negative root 3 over 2 minus, now we want cosine of 2 pi over 3. So we find 2 pi over 3. Cosine is the x coordinate, so that's negative 1/2. And finally, sine of 5 pi over 6. So here's our 5 pi over 6. Sine is the y coordinate, so that's 1/2. Now that I have all my unit circle values listed, what I need to do is, multiply, combine like terms, do all that stuff. So this gives me, what do we get? We get negative 3/4 here, minus, and that gives us negative 1/4, which gives us a negative 1/2. Okay, how's number 7? Okay, so the last concept that we're going to be looking at today is the concept about degrees, minutes, and seconds. I really think it's important for you to understand how that's created. Maybe you already know. We'll just go over it. So we have the Babylonians. It's been a long time ago, right? 1 degree, they said there are 360 degrees in a circle. 1 degree is 60 minutes, and 1 minute is 60 seconds. So if I'm going to convert this to degrees, minutes, and seconds, no, I'm not going to go in my calculator and hit the convert DMS button. I'm going to know what's going on, and that is the 35, that's whole, that's the degree part. So I can just write that down. My answer is going to be right here. I'm going to put my answer right here. Okay, that's going to be the degree part, 35 degrees. So how do I get the minutes? What do? I take the 0.72 and I multiply it by 60. Why 60? 60 because a degree is 60 minutes. That's why. I'm multiplying it by 60. When I multiply that by 60, I get 43.2. I take the whole portion of my answer. The whole portion is 43, and that turns into the minutes. Okay? We okay so far? So now I need to deal with this fractional portion. This fractional portion is going to give me my seconds. So I take the 0.2 and multiply it by 60. Why am I multiplying it by 60? Because 1 minute is 60 seconds, and that 0.2 is in terms of minutes, isn't it? And now I'm going to take it into seconds. So I multiply that by 60, and 0.2 times 60 happens to be 12. So that's my conversion, 35 degrees, 43 minutes, and 12 seconds. Okay? So yes, you would be able to use a calculator to multiply it out, but I'm going to want to see the steps. I don't want you to just use the DMS button. All right, so questions on this? We okay? I do want to talk to you just a little bit. On one of these answers up here, this was a negative. This is negative 2 pi over 3. Do we recall from last year? Did y'all talk about negative rotations last year? Okay, a positive rotation goes this way. A negative rotation goes that way. Okay, so if that's negative 2 pi over 3, I would start here and then count negative 2 pi over 3 this way. Okay. And this isn't the only time I'm going to talk about it. That's just the one time. We'll continue to talk about it. Okay? Are we all right? All right.